Hello, geometry. Welcome to Chapter 3, Parallel and Perpendicular Lines. And yes, that's right, they devoted a whole chapter to that. Let's today talk about lines and angles. A couple of definitions that we need to get out of the way. Parallel lines are coplanar lines that do not intersect. We know this hopefully from Algebra 1. We remember that parallel lines never intersect. We may have also, in our previous math lives, seen this symbol. So if you see, say, A, that reads A is parallel to B. It's kind of a really long 11. Parallel planes are planes that do not intersect. And a transversal, probably something you're not familiar with, is a line that crosses two coplanar lines at distinct points, and that should read 2. I did voice recording of that text and didn't catch that autocorrect. So let's look at what a transversal looks like. And this table is in your book. I apologize for it being blurry, but the Pearson reader is always blurry, so it doesn't matter what device I use to do the screen capture, it ends up blurry. So if you want to copy it down from, it's I think page 142 in your book, go nuts. Meanwhile, we have here our transversal. Do we see that? Let's do pink. That's our transversal right there, labeled T. And it's the same in each one of these drawings. So that's a transversal. Transversal is a line that crosses two coplanar lines at distinct points, which you can see is true here. Notice it doesn't say parallel lines, it just says coplanar, and you can see that these lines are not, lines L and M are not parallel, right? So they give us some key definitions of alternate interior angles, same side interior angles, corresponding angles, and alternate exterior angles. Nice thing about alternate interior angles is they make a Z. Same side interior angles are easy to tell because, well, they're on the same side and they're on the inside. Corresponding angles lie on the same side of the transversal and in corresponding positions. So they call out all the different corresponding angle pairs from this drawing. And you can see 1 and 5 are on the same side of the transversal and on top of their respective lines. So 1 is on top of L in the same position that 5 is on top of M. And then alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of the transversal. These are the hardest to tell sometimes. So 1 and 7, for instance. They're not adjacent. They're not on the same side of the transversal, and they're not on the inside of the lines. So that's kind of how you tell. Let's do a little practice. Man, I don't know what this mess is. A little practice on a diagram of our own. What is happening? There we go. So I'd like you to pause the video actually and look at this diagram and see if you can tell. All right, I don't know what's happening. Stand by. Stop. There we go. See if you can tell me what the angle pairs are. So for instance, the first one, if we were to say, we have 1, and we have 8. Well, those aren't on the same side. They're not on the corresponding positions, right, on top of their lines or on the bottom of their lines. And they don't make a Z. So that is an alternate exterior angle pair. I don't know what is happening. Well, I do actually. Every time I put that's alternate exterior. Every time I write, I have a tendency to rest my hand on the device and it does all kinds of crazy things. So try these on your own. Pause the video and try those on your own, and come back in a second. So 7 and 10, let's look at 7 and 10. Let's do a different color. How about green? Here's 7. Here's 10. And doesn't that look like we have a very long Z? Well, yes, it does. I'm going to call that alternate interior. What about 8 and 12? Those look to be corresponding, don't they? Don't they look like they're in the same position relative to their respective lines? So they're both on the same side of the transversal. Here's our transversal T, right? Don't lose sight of that. So this big long diagonal line is our transversal. They're both on the same side, and they are both on the same position relative to their lines, or in the case of angle 8, line segment, ray. So those are corresponding. What about angle 1 and 5? Don't those also look like they could be corresponding? I like corresponding for angle 1 and 5. And what about angles 4 and 6? These are probably the easiest to tell, right? Because they're on the same side of the transversal and they're right in a row. What is that going to be? We can call those adjacent or consecutive interior angles. I think your book uses same side interior angles, right? So consecutive or same side interior. And 8 and 9 look like those might be, does it make a Z? Let's find out. Yes, it does. It's a backward Z. But it's a Z, and those are then alternate interior angles, right? So we will do a lot of practice with